In electrical engineering, double subscripts are often used to denote voltage, but their meaning can sometimes be ambiguous. To clarify, let's explore the convention typically used when dealing with voltage subscripts like V12. V12 generally represents the potential difference of voltage at point 1 with respect to point 2. This means it is the voltage at location 1 minus the voltage at location 2. Mathematically, this can be expressed as V12 equals V1 minus V2. This convention is consistent with the idea of measuring voltage as a difference in potential between 2 points. For example, if V12 is positive, it means the voltage at point 1 is higher than the voltage at point 2. Conversely, if V12 is negative, the voltage at point 1 is lower than the voltage at point 2. Some might interpret V12 as the voltage rise from point 1 to point 2. However, this interpretation can be misleading. While the magnitude of the voltage difference is the same, the sign is opposite. Voltage rise from 1 to 2 would imply the voltage at point 2 minus the voltage at point 1, which is the negative of V12. It is crucial to adhere to a consistent convention to avoid confusion in circuit analysis. The convention where V12 represents the voltage at point 1 with respect to point 2 is widely adopted in textbooks and academic literature. This convention makes it easier to analyze circuits and perform calculations because it aligns with the fundamental principles of voltage measurement. When analyzing a circuit, always consider the reference point. The reference point, often denoted as ground, is assigned a voltage of 0 volts. All other voltages in the circuit are measured with respect to this ground. For instance, if you have a circuit with multiple nodes, you can define the voltage at each node with respect to ground. Using double subscripts, you can then calculate the voltage difference between any two nodes. The direction of current flow is related to voltage. Current flows from a point of higher potential to a point of lower potential. This is why understanding the sign of V12 is crucial. A positive V12 indicates that current will naturally flow from point 1 to point 2 if a conductive path exists. Conversely, a negative V12 indicates that current will naturally flow from point 2 to point 1. In circuit simulation software, such as SPICE, the convention of V12 representing the voltage at point 1 with respect to point 2 is standard. When defining voltage sources or measuring voltages in a simulation, the software will interpret double subscripts accordingly. This consistency is essential for accurate simulation results. Consider a simple circuit with a voltage source connected between two resistors in series. Let's say the voltage source is 12 volts. If we label the nodes as node 1, node 2, and ground, we can analyze the voltage drops across the resistors. If resistor 1 is between node 1 and node 2, and resistor 2 is between node 2 and ground, then V12 represents the voltage drop across resistor 1. The voltage at node 1 is 12 volts, and the voltage at node 2 will be some value less than 12 volts, depending on the resistor values. Similarly, the voltage at node 2 with respect to ground can be denoted as V20. V20 represents the voltage drop across resistor 2. By understanding the convention of double subscripts, you can easily calculate the voltage drops and currents in a circuit using Ohm's law and Kirchhoff's laws. Ohm's law states that voltage equals current times resistance. Kirchhoff's voltage law states that the sum of the voltage drops around a closed loop is 0. Kirchhoff's current law states that the sum of the currents entering a node is equal to the sum of the currents leaving the node. When applying these laws, it is essential to be consistent with the voltage subscript convention. If you are analyzing a more complex circuit with multiple loops and nodes, the use of double subscripts becomes even more critical. It allows you to systematically define and calculate the voltages at different points in the circuit. In conclusion, the convention that V12 represents the voltage at point 1 with respect to point 2 is the most widely accepted and useful in electrical engineering. It aligns with fundamental principles, is consistent with circuit simulation software, and simplifies circuit analysis. Remember, voltage is always a potential difference between 2 points. By understanding this concept and the associated subscript notation, you can accurately analyze and design electrical circuits. This understanding is essential for anyone working with electrical systems, from simple circuits to complex power grids. It's also important to remember that voltage is a scalar quantity, meaning it has magnitude but no direction. The direction is implied by the reference point, which is usually ground. When you measure voltage with a multimeter, you are essentially measuring the potential difference between the two probes. The red probe is typically connected to the point where you want to measure the voltage, and the black probe is connected to the reference point, usually ground. The multimeter will then display the voltage at that point with respect to ground. Understanding this fundamental principle is crucial for accurate voltage measurements. Furthermore, the concept of voltage is closely related to electric fields. Voltage is the amount of work needed to move a unit charge from a reference point to a specific point in an electric field. The electric field is a vector field that describes the force exerted on a charged particle at each point in space. The relationship between voltage and electric field is described by the equation E equals negative gradient of V, where E is the electric field and V is the voltage. This equation shows that the electric field points in the direction of the steepest decrease in voltage. Therefore, voltage is a fundamental concept in electromagnetism, and understanding it is essential for anyone working with electrical systems. In practical applications, voltage levels vary widely depending on the type of circuit or system. For example, household appliances typically operate at 120 volts or 240 volts alternating current, while electronic devices often use much lower voltages, such as 5 volts or 3.3 volts direct current. High voltage power transmission lines can carry hundreds of thousands of volts to transmit electricity over long distances. The choice of voltage level depends on various factors, including safety, efficiency, and the requirements of the specific application. Higher voltages are generally more efficient for power transmission because they reduce current losses in the transmission lines. However, higher voltages also pose a greater risk of electric shock and require more robust insulation. Therefore, engineers must carefully consider these trade-offs when designing electrical systems. In addition to understanding voltage levels, it is also important to be aware of voltage fluctuations and transients. Voltage fluctuations can occur due to various factors, such as changes in load demand or variations in the power supply. Voltage transients are short-duration voltage spikes that can be caused by lightning strikes, switching operations, or other disturbances. These voltage fluctuations and transients can damage sensitive electronic equipment. Therefore, surge protection devices are often used to protect against voltage transients. These devices typically include components such as metal oxide varistors, which clamp the voltage to a safe level. Overall, a thorough understanding of voltage is essential for anyone working with electrical systems. This includes understanding the definition of voltage, the convention for double subscripts, the relationship between voltage and electric fields, voltage levels in different applications, and the potential risks associated with voltage fluctuations and transients. By mastering these concepts, you can effectively analyze, design, and maintain electrical systems. Let's consider some practical examples of how to use the voltage subscript notation. Firstly, imagine a circuit with a battery connected to a resistor. The positive terminal of the battery is connected to point A, and the negative terminal is connected to point B. In this case, VAB represents the voltage of the battery, which is the voltage appointed with respect to point B. If the battery is a 1.5 volts battery, then VAB equals 1.5 volts. Secondly, consider a circuit with two resistors in series. The voltage drop across the first resistor can be represented as V1, and the voltage drop across the second resistor can be represented as VR2. If the total voltage across the two resistors is V, then V equals V1 plus VR2. This is a direct application of Kirchhoff's voltage law. Thirdly, imagine a circuit with a transistor. The voltage between the collector and the emitter of the transistor can be represented as Vc. This voltage is an important parameter in determining the operating point of the transistor. By controlling the base current, you can control the collector emitter voltage and the collector current. These examples illustrate how the voltage subscript notation can be used to describe the voltages in different types of circuits. By understanding this notation, you can easily analyze and design electrical circuits. It's also important to remember that voltage is a relative quantity. It is always measured with respect to a reference point. The reference point is usually ground, but it can be any point in the circuit. When you measure voltage, you are actually measuring the potential difference between 2 points. This is why it is important to specify the reference point when you are measuring voltage. In addition to the voltage subscript notation, there are other notations that are used in electrical engineering. For example, current is often represented by the symbol I, and resistance is often represented by the symbol R. These notations are standardized and are used in textbooks and technical documents. By learning these notations, you can effectively communicate with other electrical engineers. It is also important to be familiar with the units of measurement that are used in electrical engineering. The unit of voltage is the volt, the unit of current is the amp, and the unit of resistance is the ohm. These units are part of the International System of Units, which is a standardized system of measurement that is used worldwide. By using these units, you can ensure that your calculations are accurate and consistent. In conclusion, understanding voltage and the associated notation is essential for anyone working with electrical systems. By mastering these concepts, you can effectively analyze, design, and maintain electrical circuits. Remember to always be consistent with the voltage subscript convention and to use the standardized units of measurement.